So today we are going to be covering section 6.3, which is working with multiplying polynomials together. Now the key property that's going to come into play when we are multiplying polynomials is the distributive property. It's one that we've seen, we've actually already worked with up to this point in time, but now we're going to be doing this with larger, slightly more, you could say, grosser looking numbers, values, terms, and things like that. But at its core, the distributive property is what's going to make this entire section work for us, or not work for us if we don't use it properly. So first things we're going to take a look at is multiplying monomials. So the idea behind this is we're going to distribute the monomial through to each term in the other polynomial given. Then multiply each of these together individually. And we're going to find that, well, I'll go through both of these examples we have here, but we're going to find really quickly, as soon as we get to our later examples, these can become an absolute mess if you do not keep your work neat and organized for yourselves. So there's a little bit of wiggle room, as it were, for how you want to go through distributing and multiplying things together and how you want to organize that for yourself. This process you absolutely must do, but how you write that out and keep track of it, you have some wiggle room on. Again, that being said, I have seen a lot of people not keep their work organized and very quickly lose a lot of points on homeworks, lots of points on tests, and on the final exam as well, if and or when these types of problems show up. So let's go through our first two examples that we have here. Again, multiplying monomials. So these are the first two that we're going to reference over on our blackboard. Okay, so just like we have, whoops, there we go. So first two examples, we are told to simplify, which means PEMDAS, order of operations, if we're ever wondering where should we start with these things, what to do first, second, third, and so on. So our first example we've been given, 2x times the quantity 7x minus 8. And again, simplify. So can I do anything inside the parentheses? No, I cannot. I cannot combine the 7x and the 8 together. One has an x variable in it, the other has no variable in it. They are not like terms, so I cannot combine anything together. I don't have any exponents showing up, so I can't do anything with those. I have multiplication, the point of what we're doing here today, multiplying polynomials. So this 2x is going to distribute through to both terms inside of this binomial. Now again, my recommendation, you do not have to do this. You can do this multiplication in your head if you can keep track of it. But if you're not someone who is comfortable with doing a lot of multiplication and things in your head, which is fine, then write it out for yourself like this. So we have 7x times 2x minus 8 times 2x. Again, this 2x is distributing through, and it's going to multiply to both terms inside that binomial. So now from here, 7x times 2x, numbers first. 7 times 2 is going to give me 14. X times x, that's going to give me x squared. Using that, the properties from yesterday, the product rule, if the bases are the same and multiplying, the exponents add together. So x times x is the same as saying x to the first times x to the first. Bases are the same, they are multiplying, the exponents add together, 1 plus 1 gives me 2. And then for my last part here, minus 8 times 2x, multiply the numbers, 8 times 2 is going to give me, or negative 8 times 2, excuse me, it's going to give us negative 16. No other variables, so the x is just going to be there as well. Always check to see, can I combine like terms from here? And while both of these do indeed have an x in them, one is an x squared, the other is an x to the first, again, that invisible one. So these are not like terms, so I cannot combine them together, meaning I'm done. nothing else I can do. This problem is complete. So taking a look at our second example that we have in this section, we're starting with negative 3a squared b times the quantity 2a minus 4b cubed. Let's get a better 3 in there. There we go. So again, just like we did previously, we're going to use the distributive property and take this monomial out front. And it's going to distribute through to each term inside of this binomial. So again, when you are doing this, if you can multiply those two things together, so for instance, our negative 3a squared b times 2a, if you can multiply that together in your head and get the correct answer, great, good for you. I can't do that all the time, especially when we get to some later ones where these numbers get a bit grosser and there's a lot more going on. I can't keep track of that. So I would recommend, if you can't do it in your head, which is, again, perfectly fine, then write it out for yourself. 2a times negative 3a squared b, just like that, minus 4b cubed times negative 3a squared b. So regardless of which way you want to do it, if you can multiply those together correctly in your head, fantastic. If you need to write it out for yourself like this, actually show everything multiplying together, and then in our next line, which is what we're going to do now, multiply these things together, there's nothing wrong with that. If that makes it easier for you to keep track of what you're doing, how to multiply things together and not lose where you are in your problem, then absolutely do it. There's nothing wrong with that. So looking at this, let's work with multiplying our first part together here. Work with the numbers, then the a's, then the b's. I have 2 times negative 3. It's going to give me negative 6. Ooh, let's do this and keep the color pattern the same. So I have 2 times negative 3. It's going to give me negative 6. A times a squared. The bases are the same. They are multiplying, which means the exponents will add together. I get a to the third power. And I just have a b hanging out there at the very end, so nothing's changing with that. It's going to stay exactly as it is. For the last part, we have, again, work with the numbers, then the a's, then the b's. Do these things in parts. So I have negative 4 times negative 3. Negative times a negative is a positive. 4 times 3, 12. I have just an a squared in there. Nothing's multiplying with that, so a squared. And then b cubed times b. The bases are the same. They are multiplying together, which means the exponents add together. So I'm getting b to the fourth. So I have everything multiplied out, and then I'm always asking myself, can I combine like terms? Both of these terms have a's in them, and both of them have b's in them. But the exponents attached to those variables are not identical in each term. First one has an a cubed, second one has an a squared. First one is just a b value, second one is b to the fourth. So while the variables are the same, the exponents are not, and therefore I cannot combine like terms here, cannot do anything else with this problem. I am done. I have my final answer there. So this is how we work with multiplying monomials together with any other kind of polynomial that we have. Now we can and will have instances where we have a monomial out front, just like we have here, and maybe instead of a binomial that's multiplying 2, maybe it's a trinomial. It has 3 terms. Maybe it's got 4 terms or 5 terms or 6 terms. It doesn't matter. You are going to follow the same pattern with the distributive property. Take this thing and multiply it through to every single term inside the polynomial that we're multiplying it with. then multiply each of them together, and then we get our answer. So a big part of this section, if it's not apparent now, it will be with our second set of examples. A big part of this section is taking everything that we're working with and breaking it down to just do it in parts. If you try and do all of it at once, it's going to make life significantly more difficult for you. At least that's what I have tended to find for a lot of people when they go through this section. So this part are two examples here with multiplying monomials together. We'll jump back to our notes and take a look at multiplying larger polynomials together. So like we have here, as I just said, multiplying polynomials with multiple terms. Now, again, we're using the distributive property with this, but this is going to be a process that we're just going to repeat multiple times depending on what we're working with. And again, we'll have examples we'll go through with this as well. So, first thing we're doing, take only the first term of the first polynomial, distribute, and multiply it with each term of the second polynomial. So you're only going to take one thing at a time and distribute and multiply it through. Once we've done that, then we're going to repeat this with the second and third, maybe fourth, or however many terms from the first polynomial. After we've done that, after we've multiplied every single term from the first polynomial through to every term in the second polynomial, then we can combine like terms from the results of steps 1 and 2. So essentially, again, we're instead of having and taking everything and multiplying it through all at once, we're just going to take part of the first thing, multiply it through. Another part of the first thing, and then multiply it through. And then another part, multiply it through, and so on until we have everything distributed through. If you try and do all of this at once, I'm going to put money on you're going to have errors showing up. It's very common when people have that happen. So a lot of people, let's make a couple notes here. A lot of people like to say, well, I'm going to use the FOIL method to multiply these things together, or I'm going to FOIL these things out. So saying the actual FOIL method, that's unique only to multiplying two binomials together. But again, it encompasses this general process that we are using. The FOIL method for the distributive property says you're going to do multiply the first terms together, the outer terms together, the inner terms together, and the last terms together, for anyone that's unfamiliar with what the FOIL method stands for. You are not required to know that or have that memorized because, again, this is a very, very specific method that is basically just this entire thing that I described here. It just gets the name FOIL method because it's got that nice little acronym that goes along with it. But if you don't know the name of the FOIL method, you haven't seen it before, you don't need to know it. We just need to know this process. And the last thing I will note, as we are going to see this in a couple examples as well, if you are multiplying 3 or more polynomials together for a problem, only work with 2 of them at a time. So if you have 3 things multiplying together, I'm only going to work with these first 2. Distribute, multiply, simplify, done. Then work with that result in the next polynomial. Multiply, distribute, simplify, done. If there's another one after that, then work with those 2. But again, as a generality, we only want to work with multiplying 2 polynomials at once. We can and we will get to multiplying the other ones together in that problem. But if you try and do it all at once, I guarantee you're going to get wrong answers. That one I promise you on. Because we can only use these properties, this process, if we are multiplying 2 polynomials together at a time. So if we have 3 or more multiplying, you absolutely must take these in parts and solve them individually. I cannot emphasize that enough because when problems like that show up on the test, people try and do all 3 or all 4 at the same time. And oh my gosh, is it a nightmare. So we're going to take a look at these 4 examples, multiplying polynomials with multiple terms to them. And we're going to see really, really quickly, especially in examples 2 and examples 3, that you want to figure out a way to keep this organized for yourself, because this becomes an absolute mess if you don't. That'll become abundantly clear here shortly. But we'll jump over to the whiteboard, or blackboard I should say, and take a look at these things. Okay, so there's our previous examples. New line for ourselves. Okay, so our first example with the larger polynomials, we're working with 2x plus 3 times the quantity x minus 1. So I have a binomial times a binomial going on here. So again, following our process, take only the first term of the first polynomial, distribute and multiply it with each term of the second polynomial. So the first term of the first polynomial, which is this 2x, I am distributing that to every term in the second polynomial. And just like we did with our previous ones, I would recommend, if you can't do that multiplication in your head, which again, if you're in that boat, that's fine, then write out for yourself what's happening with each of those multiplication steps. So I have x times 2x minus 1 times 2x. Now we're doing the same thing with the second term of the first polynomial. So this 3. And this 3 is going to distribute through to x. It's going to distribute through to negative 1. So writing that out very similarly, just like we have there. So x times 3 minus 1 times 3. So now I have everything written out for myself in terms of I've distributed everything together. And now I can go through and individually multiply these things together. Again, I think it's very difficult for a lot of people, myself included, to keep track of what are we distributing through, what's the result, where do I have it written down for myself, or where am I at with the problem. There's a lot that's going to go on with these. So if this makes it abundantly easier for you to go through and solve these things, then you should absolutely do this. So looking at each of these piece by piece, x times 2x, give me 2x squared. Negative 1 times 2x, will be minus 2x there, plus x times 3, that's going to be plus 3x, minus 1 times 3, it's going to be minus 3. Now from here, I have everything multiplied out. And again, we're told to simplify, so multiplication, and then we go to addition, subtraction. Can I combine any like terms here? Yes, I can. I have an x term and another x term here. I can combine those together because the variables and their exponents are identical to one another. So negative 2x plus 3x, it's going to give me plus 1x, or just plus x. We have that there. I cannot combine the x and the x squared terms because while they do have the same variable, the exponents are not identical to one another, which means I cannot combine them together. So from there, we have our final answer. Why is it doing this to me? There we go. So again, this is our general process for multiplying polynomials with multiple terms together. We're going to get to some of the larger, more grosser ones here, but again, this is the main idea of how we're doing this. We're just going to get it to larger polynomials, and we're just going to be repeating steps is all. So our second example that we have, we're working with the binomial n minus 6 times the trinomial n squared plus 2n minus 7. So just like we did previously, the first term from the first polynomial is going to multiply to every single term in the second polynomial. Now, personally, I'm someone who likes seeing a visual of this, so if you like doing the little lines that show the distribution like that, you're welcome to do that. Once we get to these larger ones, basically anything beyond a binomial, I think it can become a little too messy for its own good in that regard. So if you want to write that out for yourself, you're more than welcome to. I am not going to from this example, or for this example and for our next one, because the numbers and everything are a little bit too big. But be noted, this is the process that we're going through, that n is distributing through, and then the -6 will distribute through. So again, first and foremost, distribute that n, which is the first term in the first binomial, or first polynomial, to every term in the second one. So again, n squared times n plus 2n times n minus 7 times n. So the n distributed through, fantastic. And now we're doing the same thing with the second term in the first polynomial. So again, just like we've been doing with these previous ones, I'm hoping we're starting to see this becoming very mechanical. We have n squared times -6, 2n plus 2n times -6 minus 7 times -6. So each term from the first binomial multiplies or distributes through to every term in the second polynomial. And now, again, we're just going to solve and simplify each of these things down individually. So n squared times n is going to give me n cubed, better 3. There we go. Plus 2n times n, well, that's going to give me positive 2n squared. Minus 7 times n, minus 7n. Plus n squared times -6, that's going to be minus 6n squared. Plus 2n times -6, it's going to be minus 12n. And then minus 7 times -6. Negative and a negative makes a positive, so we get a positive 42. So I distributed everything out, then I multiplied everything together, and now I'm combining like terms. And just like we did with adding and subtracting polynomials together, you have the option, if you would like to rearrange these terms to make it more apparent or organized for you of what we are and aren't combining together. It's optional, so you don't have to do it. If you'd like to take that extra line of work to do that for yourself, you are more than welcome to. I'm not going to in this instance just because I want to keep moving forward in this material. But in combining like terms, I can't combine anything with the n cubed. I have an n squared and an n squared here. So I combine those, I'm going to get, let's see, 2 minus 4, or 6, it's going to be -4. Spoiling my own work here. And then I have a -7n minus 12n. Combine those together, it's going to give me -19n. Then I have a 42 at the very end of this problem, so can't combine anything with that. It's going to be plus 42. So I've combined all like terms that I possibly can. Again, remember, it's not just the variable, it's the variable and the exponents all need to be the same to combine things together. So moving on to our third problem. And this is where it's going to get messy. So if it hasn't been abundantly clear to you up to this point in time that we need to keep our work organized, well, this problem might change your mind because it's an absolute mess if you don't. So we have the trinomial a squared minus a plus 3 times the trinomial a squared plus 10a minus 8. All right, so now we have a trinomial times a trinomial. And our process is going to be the exact same what we did with our previous examples, except now we're just going to be doing more steps with it. So we're going to distribute the first term from the first polynomial through to every term in the second polynomial. So this a squared is going to distribute through to everything in the second polynomial. Again, writing that out, we have a squared times a squared plus 10a times a squared minus 8 times a squared. Do the variables have to be listed largest to the constant? Yes, it is our standard form. Alphabetical order and by descending powers. Yes. So our next part, so that was our first term going through. We now have our second term from the first polynomial. Now that needs to distribute through to everything in the second polynomial. So we have plus a squared times negative a plus 10a times negative a minus 8 times negative a. And lastly, we take the last term, the third term, from the first polynomial, this is 3, and multiply it through to every term in the second polynomial. So again, hoping we're starting to see like this is, I think at least, this is a pretty mechanical process, pretty repetitive one. If we're not organized with it, it can become a mess really, really fast. So it's not even fitting all on the screen. Maybe that will, yeah, it kind of does it a little bit better. So again, this is every single term from our first polynomial distributing through to every term in the second polynomial. Again, there's a lot that's going on here. If it's not abundantly clear now, I'm hoping this is the problem that makes that clear to you. So there's a lot that's going on here, but if you take this in parts, small little pieces, I think it makes these problems abundantly easier. A lot of people try and do all of it at once, and more power to them if they can. I can't. I think it's an absolute pain, more trouble than it's worth to try and go through it all at the same time. But that's just my take on it. So now we're going to multiply and simplify each of these parts down individually. So a squared times a squared, bases are the same and they are multiplying, which means the exponents add. I'm going to get a to the fourth. 10a times a squared would be 10a cubed. Again, bases are same, multiplying, so exponents add. Negative 8 times a squared. Multiply the numbers together. We have an 8 and we have an invisible 1 out front of that a squared. Negative 8 times 1 gives me negative 8. We have a squared times negative a. Positive times a negative is a negative. I get a cubed. Plus 10a times negative a. Positive times a negative is a negative. 10a squared. Minus 8 times negative a. Negative times a negative is a positive. 8a. A squared times 3. It's going to give me 3a squared. Plus 10a times 3. Multiply the numbers together. It's going to give me 30a. And then minus 8 times 3, it's going to give me minus 24 at the end there. So we've condensed it down a little bit. And now I'm combining like terms where I can. So I'm not seeing any a to the fourths other than our first one. A cubed, well, I'm seeing a cubed here, a cubed, that's not an a cubed, that's an a squared. It's got 3 up front though. So I combine my a cubes together. 10 minus 1 is going to give me 9a cubed. Let's take a look at a squareds. So I've got an a squared here, and a squared here. So I can combine those together. I have negative 8 minus 10, that's going to be negative 18, plus 3, it's going to give me a negative 15. Again, you're welcome to use your calculator for these if you need to. Or you're welcome to reorganize these and put them next to each other like we did with our addition subtraction section. Either option works, it's your call. And then lastly, I've got an a term and an a term here. Combine those together. We have an 8 plus 30, it's going to give me 38. And at the very end, I just have a minus 24. I'm checking to see again, can I combine any other like terms at this point in time? No, I cannot. So I have my final answer. So again, if it isn't abundantly clear, wasn't abundantly clear before this, you are going to have a lot that's going on with these problems potentially. And again, I think these problems are most difficult if you do not keep your work very neatly organized. You are very methodical with how you go through and solve it, and you do not rush yourself. Looking at each of these parts individually, a squared times a squared. Did this yesterday with our 6.1 or 6.2 material, I think it was. And individually, this I don't think it's too terrible for us to do. I think it's one of the easier things that we've worked with throughout this entire quarter. So if you do this, just that part, there you've got it. Do just that part, there you've got it. You can go individually through each of these. But if you are trying to do all of this at once in your head, keep track of all of that, good luck to you. I can't do that. I don't expect you guys to do that. Write this out for yourself and keep it organized. Again, if we get this process, this procedure down, there's very little thinking that's involved in it at that point in time. You're just following the process. You don't really need to do a whole bunch of extra thought on it. Okay. Now our fourth example, I'm going to go through. Don't worry, it's not going to be as messy as this one. It does have a little bit of a twist to it, but I don't think it's going to be as messy. I don't think it normally gets as messy, I should say. So our fourth example that we have here, we have x times x minus 1 times 2x plus 2. Now again, this is an instance, as I did note in the section notes, but this is one of the ones that comes up. If we have, or we're multiplying 3 or more polynomials together for a problem, only work with 2 of them at a time. Do not do all of them at once. So I have 3 polynomials multiplying together here. You just need to pick 2 of them and just work with those 2 for now. The other one is going to just be along for the ride, and we will deal with it later. But you can only work with 2 polynomials at a time. You cannot work with more than that. If you do, you're going to get wrong answers. I cannot emphasize this enough because it's a very, very common mistake that can be very easily avoided by just doing that. I don't know any other way to put it. So for this problem, I'm going to choose to work with the x and x minus 1 terms first. The 2x plus 2, we will get to that later, but I'm just going to simplify these 2 polynomials before I do anything else. So make it abundantly clear to yourself which 2 am I working with, and then just work with those. And while I'm choosing x and x minus 1, you could just as reasonably choose I'm going to multiply x minus 1 and 2x plus 2 together. Great, that will work. You just need to pick 2 and move forward with it. So for these ones, just x and x minus 1. Again, I'm distributing x through to both terms in the parentheses. So it's going to give me x times x minus 1 times x. This 2x plus 2 at the very end, it's just along for the ride. You still have to list it, but we're not doing anything with it right now. Simplify inside these parentheses, I have x times x, it's going to give me x squared. Minus 1 times x is going to give me minus x. And I can't do anything else with that first polynomial, which is fine. But now, those first 2 polynomials have just condensed down into being x squared minus x. And now, I only have 2 polynomials multiplying together, and now those are the only 2 that I'm going to multiply. So the first term from the first polynomial distributes through to every term from the second polynomial. So 2x times x squared plus 2 times x squared. Oops. There we go. And then the second term from the first polynomial distributes through to every term in the second polynomial. So 2x times negative x plus 2 times negative x. So we're just listing everything out. So it's going to multiply together. And now I'm going to actually multiply everything together. So I have 2x times x squared. It's going to give me 2x cubed plus 2 times x squared. So that's going to be plus 2x squared plus 2x times negative x. So positive times a negative is a negative. I'm going to have a 2 and x squared. And at the very end, I have plus 2 times negative x. Positive times a negative is a negative. I get 2x for my answer there. So now I combine like terms where I can. I don't have any other x cubes showing up, so that's just going to cube terms falling down there. I have x squared and x squared. 2x squared minus 2x squared. Positive 2 minus 2, that just becomes 0. 0 times x squared, gone entirely. Those things cancel each other out. And I'm just left with a minus 2x at the very end. I cannot combine any like terms anymore here. So we have our final answer of 2x cubed minus 2x. And I can't do anything else from there. So again, I cannot emphasize this enough. If we have 3 or more polynomials multiplying together. Doesn't matter if it's binomials and monomial, if they're all binomials, if they're all trinomials, if there's a combination, mix and match of those, does not matter. If I have 3 or more polynomials multiplying together, only work with 2 of them at a time. If you work with all of them at once, I guarantee you're going to get wrong answers because we cannot mathematically work with them that way. You cannot take, using this one as an example, you cannot take this x and distribute it through to this binomial and then this binomial, because effectively that's going to kind of distribute it through multiple times. So we can only work with 2 of these at a time. And again, it is your choice as to which 2 you would like to work with at a time. It does not matter which ones you choose, but you have to choose 2 and move forward with them. Once those are simplified, then you choose the next 2 that you want to work with. Multiply and simplify. Then you choose the next 2 you want to work with, and so on until you have everything done. But again, only 2 at a time. A lot of people, once again, a lot of parts of math want to go through everything quickly, not necessarily correctly. There's a big difference between those two. They can go hand in hand, but then not always. So this is everything that we have for the 6.3 material, where we are multiplying polynomials together. So I'll end our recording here.